talking about linear inequalities today. And so we're going to graph both linear and absolute value inequalities. And so first of all, a linear inequality, it looks like a linear equation, but notice it has an inequality sign instead of an equal to sign. And so if you notice, I have y is, what is that symbol? Less than negative 3x minus 2. So remember, in order to graph this, my slope is negative 3. My y-intercept is negative 2. And so if you notice, I'm going to graph that the exact same way. My y-intercept is negative 2 here. A slope of negative 3 means you're going to go down 3 and then over 1. And then I'm going to connect those dots and draw a line through it. The thing here is you're going to notice that the line is dashed. The reason why it is dashed is because there is no equal to sign. If this had been less than or equal to, you would have used a solid line. And then we're going to shade on one side of the graph or the other. And so what this means is that everything here in the blue, every ordered pair, will satisfy that inequality. So now what we're going to do is look at this one. So I need you to follow along. You've got your graph paper, you've got your colored pencils. You can go ahead and we're going to graph this together. So I need you to go ahead and make a coordinate plane. This says graph x plus 2y is greater than 4. So in order to solve this, what I need to do is put this in slope-intercept form. I need to put this in slope-intercept form. And so how do you do that?
Y equals mx.
Yep, y equals mx plus b. So the first thing I'm going to do is subtract x. Okay, we're not going to graph these using GeoGebra. On your test, you're going to have to graph these from by hand. And so if I subtract x, I've got 2y on the left side is greater than negative x plus 4. Now, does everybody see what I have done right there? All I did is subtract x. I'm getting the y by itself. What do you need to do now? Divide by 2. Good. Now I'm going to divide everything through by 2. So I get y is greater than negative 1/2 x plus what? 2. So what that tells me is that my slope is what?
Negative 1/2.
Good, negative 1/2. What is my y-intercept? 2. So I'm going to come over here to my graph, and I'm going to put a dot at 2.
We have to do this in color
Okay.
pencil.
Yeah, you can, if you want to do this in colored pencil, that's fine. The shading is why you've got the colored pencils. And so then now I need to graph a slope of negative 1/2. And so then what do you do from this 2? How do you do a negative 1/2?
Oh.
Down 1 and then over 2. Down 1 and over 2. Now when I connect those dots, am I going to connect those using a dashed line or a solid line? I'm going to use a dashed line because of this symbol right here. The only way you would use a solid line is if it had an equal to sign below it. And so now I need to go ahead and connect those with a dashed line. So if you want to go ahead and get your colored pencils, that's fine. And go ahead and connect those. And so now, after you're drawing that in, we've got to figure out which side do we shade. We've got two options, right? I've got this option up here, which I'm going to call option 1, and I've got option 2 down here. And I need to figure out which side do I shade. And so this line right here is kind of like the boundary. So what I'm going to do is I'm going to pick a point either in region 1 or region 2. So I'm going to pick a specific point. Now notice the point can't be on the line. So in this case, I'm going to pick this point right here. Why would I pick 0, 0 or something with 0? Because it's the easiest way to plug that in. So now what I'm going to do is I'm going to take that point 0, 0 and I'm going to plug that in up here into that inequality. So when I plug 0 in, I get 0, right? Plus what? 2 times 0, which is 0. So basically I get 0 plus 0, which is 0. Okay, so on the left side I get 0. I have my greater than sign 4. Is that a true inequality? Is 0 bigger than 4? No, so that means this side here doesn't work. Because 0, 0 is on this side, so this side doesn't work. So where am I going to shade? I'm going to shade here in region 1. So let's go ahead and shade that. So what that means is that any point here in region 1, any point here that I'm shading in pink will fit that inequality. Any point there will fit that inequality. Now eventually what's going to happen is we're going to have multiple inequalities, not this chapter, but we're going to throw another one in there and we'll get a shade both ways too. And we'll find out which one works for both. So let's look at this one, graph. 2x plus 1/2 y is less than or equal to 2. What do I want to do? I want to what? Get the y by itself. So what do I need to do? Subtract 2x. Very good. So on the left side, I end up getting 1/2 y is less than or equal to negative 2x plus 2. What do you do now? Divide by 1/2 or times by 2/1, which is what you said. Now the big thing you need to remember is that you're going to multiply everything, all three terms, by 2/1. So on the left side, what are you left with? Y is less than or equal to, what is 2 times negative 2x? Negative 4x plus 4. So what does that tell me? What is your slope? Negative 4, very good. What's your y-intercept? 4. So that means I'm going to come up to 4. 1, 2, 3, 4. Put a dot. So I'll let some of you go ahead and get started. I see some of you are still getting started graphing. So then this is my y-intercept, right? So what's the slope of negative 4 mean that you do? Down 4/1. Now for those of you wondering, how do you know it was down 4/1? I can write negative 4 as a fraction. It's negative 4/1. And so what that means, remember slope is rise over run. So what that means is I'm going to go down 4 because it's a negative, so rise has to go down. So I went down 4, my run is 1. So from this point, what are you going to do? Go down 4 again and over 1. Then what are you going to do? Draw your line through, okay? I want you to try and figure out what side you're going to shade now.
I'm just going up there.
Yes?
How come on the other one you went down 1/2?
Because that one was 1.
Oh,
So it was negative 1/2. Good job. I already see that some of you have used a solid line. That's a nice job. Okay, if you didn't, just go ahead and fill in the lines, but remember it should be solid because it is equal to. Oops, I need to redo that line.
It's hard to draw lines straight.
Oh, look at my line. Okay.
Where do we go after we get, like, after we plugged in 0, 0?
What'd you get?
0 is less than.
Is that true?
Yeah.
Whoa.
So you're going to shade which side?
Oh, wait. No, it's not.
0 is less than 2.
It's better than 1.
Okay, you just look at the inequality. It's less than, right? Less than 4 equals. Say 2, right? Okay, so now I see that some of you have already been plugging in 0, 0. And that's a great point to plug in because remember we have two regions here, 1 and 2. This point right here, let's plug it in. So if you plug 0 in here, you end up getting 0 is less than or equal to 2. Now, I know that equal to can kind of throw some people off, so you know what, we're gonna just disregard that equal to. And I want to know, is 0 less than 2? And the answer is yes. So that means 0, 0 is true. That works. So this is the side you want to shade.
So the 2 is if it's true and the 1 is if it's false.
No, you shade if this is a true statement. You shade that side. If that is true, you will shade this side, the side with 0, 0. If that is false, that means 0, 0 doesn't work, so you've got to shade the other side.
You always use 0 to plug in.
You can use 0, 0, 0 as long as it's not on the line. Say, for example, I would have had a line, and my line would have went like this. You can't use 0, 0 then because it's on the line, so you would have had to pick another point. Okay. You could pick 1, 0. It's good to try and pick a point with 0 in there because it's easy to plug in. And that's a good question. So now's where you need your GeoGebra. Okay, now we're going to do the same thing, but we're going to do absolute value graphs. So go ahead and get out your netbooks. And I need you to go ahead and graph this. Now you're not going to be able to enter that in as y is greater than. You're going to have to enter this in as y equals abs x minus 4. Now all we're doing with GeoGebra is we're getting a picture of the graph, how it looks. That's all we're doing here. We're going to do a lot of work on our own. So when you get that graphed, what I want you to do is go to your graph paper and go ahead and draw that same graph in. So when you get that graphed, you are translating your graph from what you see on the netbook, and you are putting it onto your graph paper. Now, when you put this in on the graph paper, do you think you're going to use a solid line or a dashed line? Dashed. So when you graph this, okay, you're going to have to understand that this is a dashed line. Oh, shoot. So I think when all is said and done, you should get something that looks very similar to what I have over there on the board. Okay? Now, like I said, mine's going to be a little different than what you see in your GeoGebra screen because you're going to see solid lines.
We just graph it just how it looks.
This is not right. How do I? Mine's at 0. Oh no, it's not. It's just because you're zoomed out.
You go from -268, so let's change that to about -6.
Oh, there we go.
Let's change the y-axis to
Okay, so now if you notice, just as with the line, I have two regions. I have one inside the absolute value, inside the V, and I have one outside the V. So I have, if I would call these, I could call this just region 1 and region 2. Now, is there any rhyme or reason to what I'm calling 1 or 2? No. It's just whatever, it's the first one I picked. So the first one here I picked is the one inside the V. So I need to pick a point in one region or the other.
0,
0, 0. So now I'm going to plug 0, 0 in, and I'm going to see, do I shade inside the V or outside the V? So let's plug in 0, 0. Now, when you plug this in, you need to make sure that you plug it into the original inequality, because if you plug it in here to the equal sign, it's not going to work. So if I plug 0, 0 in over here, I end up getting 0 is greater than, what do you get from the right side? -4. Is that true? Is 0 bigger than -4? Yeah, so I want to shade this side with the 0, 0. So I'm going to go ahead and shade inside the V. So let's revisit again what that means. Anything shaded here in pink, anything shaded in there, makes that inequality true. So that inequality has a ton of solutions. All right, let's look at another one, okay? So y is greater than or equal to 3 times x, the absolute value of x plus 1. So what we're going to do is use GeoGebra to graph that. So go ahead, graph that. Translate your graph to your graph paper.
Why is it letting me delete this?
Now in the new updated versions of GeoGebra, they're going to do the inequality graphing, but for right now, the version that you're working with doesn't do that.
How do you put it in? Like, well, like, what do you
Three.
mean
What you're going to do is do 3.
first?
Yep.
Okay.
So, if some of you are struggling with how to put it in, it's just going to be y equals, or y is equal to 3 abs
Why do you put the 3 before that?
x plus 1.
Why do you put the 3 before that?
Because it's 3 times the absolute value.
Did I put that in there? Almost, you forgot your x plus 1. There you go.
Mine is like, it's supposed to be small.
Yeah. Narrow, you mean?
Yeah, like.
Yep. I'm actually going to graph it shortly, what you should end up getting.
Wait, what do you do?
Oh, what did I do wrong? I shouldn't have done that. Silly. There we go. That's what we should have. Okay, so remember this line is not dashed. That is what you should get, it is not dashed because there's an equal to sign right there. And so now you need to pick one point on one side. So I could pick a point inside the V or a point outside the V. What point do you want to pick?
0, 0.
0, 0. So that's the outside of the V. So let's plug 0, 0 in. So is 0 greater than 3 times 0 plus 1? So is 0 greater than 3? Is that true?
No.
No, so I don't want to shade here. Where do I want to shade? Inside the V. So revisiting again what that means. Anything that's shaded pink, any point, will satisfy that inequality. So instead of having like one solution with an equation, with an inequality here we have numerous solutions. So the only way to represent those is to shade.
And that's side 1.
It doesn't matter. It doesn't. I was just calling those so that you would see that they're two separate regions. That's why I called them 1 and 2. Okay. All right, so your assignment then is going to be to do some of this. Now, the first few you can do by hand. You don't use GeoGebra for those. You will only use GeoGebra for the last I believe it's 5 or 6 problems. Okay, if you need graph paper, it is in my top drawer. You can use that. The other thing, is I would suggest you get going on the absolute value ones now, while we've got the net books, because you can always do the line ones on your own.
On the last lesson.
What?
The last